What if a single forgotten seed, sitting quietly in ancient kitchens for thousands of years across India and China, could hold clues to how your body repairs itself at a cellular level? What if something as simple as a traditional food might influence how your aging process unfolds, how your immune system responds, and how your body handles damaged cells long before disease begins? In this video, we are exploring a seed known as makana, also called foxnuts or lotus seeds. It has been used in traditional Ayurvedic and Chinese practices for more than 3,000 years. Ancient healers valued it for strength, longevity, and vitality, but they never had the tools to fully explain why it worked. Today, modern research is beginning to explore those answers. Before we go further, it is important to be clear. The information shared here is based on scientific studies and traditional knowledge, but it is not a replacement for medical treatment or professional advice. It is an exploration of how nutrition may interact with the body at a biological level. My focus over the past decade has been studying how traditional foods connect with modern research on disease prevention and aging. Across thousands of published papers, a pattern appears again and again. Certain whole foods contain compounds that may support cellular health in ways that isolated supplements cannot fully replicate. And that is what makes makana so interesting to researchers. It is not an expensive extract or synthetic compound. It is a simple, natural food that has been part of human diets for centuries. Now, before we go deeper, I want you to stay with this entire discussion, because later we will look at research exploring how compounds in this seed interact with stem cells and cellular repair systems. We will also examine how it may influence inflammation, metabolic balance, and even pathways studied in cancer biology. Some of these findings come from laboratory and early stage studies, and they are still being explored by scientists. Here is what we will cover step by step. First, why the body's natural repair systems, especially stem cells, tend to decline with age, and what researchers believe contributes to that process. Second, what compounds have been identified in makana that may interact with these biological systems? Third, what early research suggests about its influence on damaged or abnormal cells in controlled laboratory environments? Fourth, how it is traditionally prepared and consumed in different cultures. And finally, a real-world case example of how dietary changes, including the seed, were incorporated into a broader lifestyle approach. Let us begin with the bigger picture of aging at the cellular level. As the body ages, one of the key changes researchers observe is a gradual reduction in stem cell activity. Stem cells are often described in science as the body's internal repair system. They play a role in maintaining tissues such as the heart, liver, immune system, and even parts of the brain from around midlife, typically after the age of 40. Studies suggest that stem cell activity does not remain as strong as in earlier years. At the same time, inflammation levels in the body tend to rise due to multiple factors, including diet, stress, environmental exposure, and sleep patterns. This combination of reduced repair capacity and increased inflammation is one of the areas researchers are actively studying in relation to aging and chronic disease development. One widely cited study published in Nature in 2016 discussed how chronic inflammation is associated with accelerated aging processes at the cellular level. While this does not mean inflammation directly causes disease on its own, it is considered one of several contributing factors that influence how quickly cells function and repair over time. At the same time, cancer biology research focuses heavily on how damaged cells are normally identified and removed by the body. This process, known as programmed cell death or apoptosis, is essential for maintaining healthy tissue balance. When this system becomes less efficient, abnormal cells may persist longer than they should, which is why it is studied so closely in oncology research. This is the biological foundation behind much of today's discussion around diet, longevity, and cellular health. Researchers are not suggesting that food alone can prevent or treat disease, but they are increasingly interested in how nutrition may support or influence these internal systems. And this is where makana becomes relevant in scientific discussions. Known scientifically as Euryale ferox, macana grows in wetland regions of Asia, including India, China, Japan, and Korea. In traditional systems like Ayurveda and classical Chinese medicine, it has been used as a nourishing food, often associated with strength and vitality. Modern analysis has identified several naturally occurring compounds inside the seed, including flavonoids and plant-based antioxidants such as quercetin derivatives and KM-ferol. These compounds are widely studied in nutritional science for their role in oxidative stress and cellular protection. Some early laboratory studies have also examined polysaccharides extracted from macana and their interaction with immune-related cell activity. In controlled environments, researchers have observed that these compounds may influence pathways involved in cell growth and immune signaling. It is important to understand that these findings are still being studied and do not directly translate into clinical outcomes in humans. However, they provide a foundation for why this traditional food is receiving renewed scientific interest. Nutritionally, macana is relatively light in calories, contains plant protein, and provides minerals such as magnesium, potassium, and phosphorus. It also has a low glycemic index, which means it does not cause rapid spikes in blood sugar when consumed as part of a balanced diet. But beyond nutrition labels, what scientists are trying to understand is how these natural compounds interact with biological systems over time, especially when consumed regularly as part of a consistent diet, and that is exactly what we will explore next. Starting with how specific compounds in macana are being studied in relation to stem cell activity and cellular regeneration pathways. To understand why macana has drawn attention from researchers, we need to go deeper into what happens inside the body when these plant compounds interact with cellular systems over time. The interest is not based on hype, but on a series of laboratory findings that are slowly building a clearer picture of how natural food compounds may influence biological repair processes. One of the most discussed areas of research is stem cell activity. Stem cells are not magical cells, but they are essential. They are the raw material your body uses to replace damaged or worn out cells across nearly every system, including blood, immune tissue, and internal organs. Without them functioning properly, repair slows down, and the body becomes more vulnerable to age-related decline. Researchers studying aging have consistently observed that stem cell activity decreases with age. This is not a sudden drop, but a gradual reduction influenced by genetics, inflammation levels, and environmental stressors. What makes this more complex is that chronic inflammation doesn't just reduce stem cell efficiency, it can also create an environment where regeneration becomes harder to maintain. In laboratory studies focusing on Euryale ferox, the scientific name for macana, researchers have identified several bioactive compounds that appear to interact with pathways linked to cellular signaling and immune regulation. These include flavonoids such as quercetin, related compounds, and KM-ferol, both of which are widely studied in nutritional science for their antioxidant properties. Antioxidants, in simple terms, help the body manage oxidative stress. Oxidative stress is a condition where unstable molecules, often called free radicals, can damage cells if they accumulate in large amounts. While this is a normal part of metabolism, excessive oxidative stress over time is associated with faster cellular aging and tissue dysfunction. One area of particular interest in macana research involves polysaccharides extracted from the seed. In controlled laboratory environments, some studies have observed that these compounds may influence hematopoietic stem cell activity, which refers to stem cells responsible for generating blood and immune system components. For example, research published in journals such as the Journal of Ethnopharmacology and Food Chemistry has explored how plant-derived polysaccharides interact with signaling pathways involved in cell communication. These pathways include mechanisms that regulate whether a cell remains inactive, repairs itself, or undergoes division. One signaling pathway often mentioned in research discussions is the Wnt beta-catenin pathway. This is a complex biological system involved in cell growth and regeneration. It does not act alone, and it is influenced by many internal and external factors, including inflammation, nutrient availability, and hormonal balance. Some laboratory findings suggest that certain compounds in macana may interact with this pathway under controlled conditions. However, it is important to be precise here. These are early stage findings, mostly observed in cell cultures or experimental models, not definitive human clinical outcomes. What makes this area of study important is not the idea of a switch being turned on or off, but rather how consistently the body's internal signaling systems respond to long-term dietary patterns. In nutrition science, the focus is always on patterns over time, not isolated effects from a single food. At the same time, researchers studying cancer biology are interested in how natural compounds influence processes like apoptosis, which is the body's built-in system for removing damaged or abnormal cells. This process is essential because it helps prevent malfunctioning cells from continuing to divide. When apoptosis functions properly, the body maintains balance. When it is disrupted, abnormal cells may persist longer than they should. This is one reason why apoptosis is heavily studied in cancer research, although it is not exclusive to cancer biology and is part of normal cellular maintenance. Some laboratory studies on plant compounds found in macana, including flavonoids like quercetin derivatives, have shown activity in controlled environments where cancer cell lines are studied. These studies often examine whether compounds can influence cell behavior, including growth inhibition or programmed cell death in isolated conditions. It is crucial to understand what this means scientifically. These are in vitro studies, meaning they take place in a controlled lab environment, not inside a human body. They are used to understand potential biological mechanisms, not to make clinical claims. Another area researchers focus on is inflammation regulation. Chronic inflammation is increasingly recognized as a key factor in many age-related conditions. It does not act alone, but it influences multiple systems, including cardiovascular health, metabolic function, and immune response. Macana contains natural plant compounds that are being studied for their antioxidant potential. Antioxidants help neutralize oxidative stress, which is one of the contributors to inflammation at the cellular level. Again, this does not mean it eliminates inflammation completely, but it may contribute to a more balanced internal environment when consumed as part of an overall healthy diet. Nutrition researchers often emphasize that no single food works in isolation. The body responds to patterns of intake, lifestyle, sleep quality, stress levels, and physical activity. This is why traditional diets, which included foods like macana regularly, are now being studied as complete dietary systems rather than individual ingredients. In the next section, we will move beyond stem cell research and inflammation to explore another major area of scientific interest: how compounds in macana are being studied in relation to abnormal cell growth, metabolic regulation, and tumor-related biological pathways in laboratory settings. As we continue, we now move into one of the most sensitive and widely discussed areas of modern biomedical research: how natural compounds interact with abnormal cell growth in controlled laboratory environments. This is also where macana has gained attention in scientific literature, not as a treatment or cure, but as a source of bioactive compounds that researchers are studying for their biological effects. To understand this properly, we need to be very clear about what science actually measures. When researchers study plant compounds like those found in Uriel ferox, they often isolate specific molecules and observe how they behave in cell cultures. These are highly controlled environments where scientists can see how certain compounds interact with specific types of cells, including both healthy and abnormal ones. One of the most studied processes in this context is apoptosis, also known as programmed cell death. This is not a disease-related mechanism on its own. It is a normal biological process that allows the body to remove damaged or unnecessary cells in a controlled way. Without apoptosis, the body would struggle to maintain healthy tissue balance. In cancer research, apoptosis becomes particularly important because cancer cells often develop the ability to avoid this natural self-destruct mechanism. This allows them to continue dividing when they should not. That is why many areas of oncology research focus on understanding how apoptosis can be influenced in controlled conditions. Some laboratory studies involving compounds found in macana, especially flavonoids like quercetin, derivatives, and K-ampherol, have shown interesting activity in isolated cancer cell lines. These studies, published in journals such as the Journal of Agricultural and Food Chemistry, examine whether these compounds can influence cellular behavior under controlled experimental settings. In these environments, researchers have observed that certain plant-derived compounds may affect how cancer cell lines grow or respond to stress signals. In some cases, they may trigger pathways associated with cell cycle regulation or programmed cell death. However, this is strictly within laboratory conditions and does not represent clinical treatment outcomes in humans. Another area of research focuses on angiogenesis, which is the process by which new blood vessels form. Tumors, like any growing tissue, require a blood supply to receive oxygen and nutrients. Without angiogenesis, their growth is limited. Some studies on plant flavonoids have explored whether these compounds can influence angiogenic signaling pathways in experimental models. Again, this is not about blocking or treating disease directly, but about understanding how natural compounds interact with complex biological systems. What makes macana interesting in this context is the combination of multiple bioactive compounds rather than a single isolated ingredient. The seed contains a range of plant-based chemicals, including antioxidants and polysaccharides, which researchers believe may work together in subtle ways that are still being studied. At the same time, it is important to emphasize a key scientific principle. Results from cell studies do not automatically translate into effects inside the human body. The human system is far more complex. Absorption, metabolism, dosage, and individual health conditions all influence how any compound behaves once consumed. This is why researchers are careful with language. They do not say, this food kills cancer or this compound prevents disease. Instead, they say things like shows activity in vitro or demonstrates potential biological effects in controlled models. The difference is critical for scientific accuracy. Even so, these early findings help build a foundation for future research. They guide scientists toward understanding which compounds may be worth studying further in animal models or eventually in clinical trials. Most compounds never go beyond early stages, but some do. And that is how medical science slowly progresses. Alongside this, researchers are also studying oxidative stress and its role in cellular damage. Oxidative stress occurs when there is an imbalance between free radicals and the body's ability to neutralize them. Over time, this imbalance can contribute to cellular dysfunction. Macana contains plant antioxidants that are being studied for their ability to reduce oxidative stress markers in experimental settings. These antioxidants do not act as a cure, but they may support the body's natural defense systems by reducing unnecessary cellular strain. Another important area of interest is metabolic health. Early studies have examined how macana, due to its low glycemic index and resistant starch content, may influence blood sugar response. In control trials, foods with similar profiles have been associated with slower glucose absorption and improved post-meal blood sugar stability. This matters because metabolic imbalance is closely linked with inflammation, and inflammation is one of the key areas being studied in relation to aging and chronic disease development. Again, this does not mean one food can reverse complex conditions, but it does show how dietary patterns can influence biological markers over time. In traditional systems of medicine, macana was never viewed as a single function food. It was part of a broader dietary philosophy focused on balance, digestion, and long-term vitality. Modern research is now re-examining these traditional practices through the lens of molecular biology and nutrition science. What we are seeing is not a replacement of traditional knowledge, but a slow alignment between ancient dietary practices and modern biochemical understanding. In the next section, we will move away from laboratory science and focus on something more practical: how macana is actually used in real diets, how preparation methods change its nutritional profile, and why timing and combination with other foods may influence how the body responds to it. Now that we have explored the laboratory findings and the biological interests behind makana, we need to shift from theory to practice because science alone is not what determines health outcomes in real life. What truly matters is how a food is consumed, how consistently it is used, and how it fits into the overall pattern of a person's diet and lifestyle. Makana, or Uriale Ferox, is not a modern discovery. It has been part of traditional diets across India, China, and parts of East Asia for thousands of years. In these cultures, it was never treated as a rare supplement or medical intervention. Instead, it was consumed as a daily food, often prepared in simple ways that preserved its natural properties. In Ayurveda, makana was considered a nourishing food that supported balance in the body. It was often recommended for individuals needing steady energy, digestive support, or recovery after illness. In traditional Chinese dietary practices, it was also associated with strengthening the body and supporting longevity, especially in older adults. What is interesting from a modern nutritional perspective is that these traditional uses were based on observation, not laboratory analysis. People noticed long term effects across generations, even without understanding the biochemical reasons behind them. Today, researchers are beginning to study how preparation methods affect the nutritional profile of makana. Like many plant foods, its properties can change depending on whether it is roasted, soaked, or cooked with other ingredients. One of the most common methods of consumption is dry roasting. In this method, raw makana seeds are gently heated in a pan without oil until they become light and crispy. This process not only improves texture but also reduces moisture content, making them easier to store and digest. From a nutritional standpoint, dry roasting preserves most of the protein and mineral content while slightly altering the starch structure, which can make it easier for some people to digest. A small amount of healthy fat, such as ghee, is often added after roasting in traditional diets. This is not just for taste. Fat soluble compounds in plant foods are generally absorbed more efficiently when consumed with dietary fat. Another traditional method is soaking and cooking makana into porridges or milk based preparations. When soaked, the seeds soften and the resistant starch content becomes more accessible. This is one reason why they are often used in slow digesting meals in traditional systems of nutrition. In modern dietary discussions, resistant starch is of interest because it behaves differently from regular carbohydrates. Instead of being rapidly broken down, it is digested more slowly, which can result in a steadier release of glucose into the bloodstream. This is why foods with resistant starch are often studied in relation to metabolic health and blood sugar regulation. Makana also contains a modest amount of plant protein and minerals such as magnesium, potassium, phosphorus, and zinc. These nutrients play roles in muscle function, nerve signaling, and overall metabolic balance. While the quantities are not extremely high compared to concentrated supplements, they contribute to its overall nutritional value when consumed regularly as part of a diet. Another important aspect is portion size. In most nutritional research discussions, consistency is emphasized more than excess intake. Makana is typically consumed in moderate amounts, often as a snack or part of a meal, rather than in large quantities. This aligns with traditional dietary patterns, where foods are integrated into daily routines rather than used in isolated high doses. Researchers studying dietary patterns often highlight that long term health outcomes are influenced more by consistency than intensity. In other words, small, repeated dietary habits tend to have a greater impact than occasional large changes. Timing also plays a role in traditional use. In many households, makana is consumed in the morning or as an evening snack. Some also include it in nighttime routines, often combined with warm milk or other calming ingredients. While modern science does not prescribe exact timing for benefits, studies on digestion and metabolism suggest that food timing can influence how nutrients are processed by the body. Another area of interest is food combinations. In traditional dietary systems, makana is rarely eaten alone in therapeutic contexts. It is often paired with ingredients like ghee, turmeric, nuts, or herbs such as ashwagandha. These combinations were designed based on traditional knowledge of balance and absorption. And some of these combinations are now being revisited in modern nutritional research for their synergistic effects. For example, fat based carriers like ghee may enhance absorption of certain plant compounds. Spices like turmeric contain curcumin, which has been widely studied for its anti inflammatory properties. When combined in food, these ingredients may interact in ways that researchers are still trying to fully understand. It is important, however, not to oversimplify this. Food synergy is a complex area of study, and effects can vary widely depending on individual health, metabolism, and overall diet. What remains consistent across both traditional practice and modern research is the idea that makana is best understood as part of a broader dietary pattern rather than a standalone solution. It is not a medicine. It is a food that contains compounds of scientific interest and has been valued historically for its role in supporting general well being. In the next section, we will move into real world application and case based observation. We will look at how dietary changes, including the introduction of makana into a structured routine, were combined with broader lifestyle adjustments in one individual case and what measurable changes were observed over time in a clinical context. To understand how something like makana fits into real human health outcomes, we need to move away from isolated science and into real world context. Because in actual life, no food works alone. It always interacts with sleep, stress levels, activity, medication, and overall dietary habits. This is where case based observation becomes important. It does not replace clinical trials, but it helps illustrate how nutritional changes are applied in practical settings under medical supervision. Let me share a real clinical example with identifying details changed for privacy. Um, a uh, 62-year-old woman came into consultation after routine blood tests showed concerning trends. Her inflammatory markers were elevated, and her cancer screening marker, CA 125, was rising above her previous baseline. She was not diagnosed with cancer, but her physician described her condition as high risk metabolic and inflammatory imbalance. Beyond the lab results, her daily life was also affected. She reported persistent fatigue, difficulty concentrating, and episodes of memory lapses that were beginning to interfere with her confidence in everyday tasks. She described it as feeling like her mind was slowing down, even though she was still active and independent. Her medical history did not show any single cause. Instead, it was a combination of long term stress, inconsistent sleep, and a diet high in processed foods and low in whole plant based nutrition. The approach taken was not aggressive medical intervention, but structured lifestyle correction under supervision. The goal was to reduce inflammatory load, improve metabolic stability, and support overall cellular health markers over time. One of the dietary adjustments introduced was the inclusion of makana as a daily food. The instruction was simple and consistent rather than complex. She was advised to consume a moderate portion each morning, lightly roasted with a small amount of ghee, along with other dietary improvements such as increased hydration, reduced processed sugar intake, and better sleep timing. It is important to understand that makhana was not used as a treatment. It was part of a broader nutritional strategy aimed at improving dietary quality and consistency. During the first few weeks, the most noticeable changes were subjective. She reported slightly improved energy levels and better morning alertness. These early changes are common when diet quality improves, but they are not considered diagnostic or conclusive on their own. At around 6 weeks, follow-up blood work showed measurable changes. Her inflammatory markers had decreased compared to baseline. While still within a monitored range, the downward trend was considered positive by her physician. She also reported improved sleep quality, which is significant because sleep plays a major role in regulating both inflammation and immune function. Better sleep alone can influence multiple biological markers, making it an important factor in overall health improvement. By the 12-week mark, Additional testing showed further stabilization of her metabolic indicators. Her CA 125 levels had returned closer to her previous baseline range, and her energy levels had improved enough that she was able to resume regular morning walking routines, which she had previously struggled to maintain. It is important to interpret these results carefully. No single food can be credited for complex physiological changes. Instead, these improvements were the result of a combined approach that included dietary restructuring, improved sleep, reduced stress exposure, and consistent nutritional habits. However, what made Makana relevant in this case was its role as a stable, repeatable part of her daily routine. In nutrition science, consistency is often more important than intensity. A food that is simple, well tolerated, and easy to include regularly can have more practical impact than complex interventions that are difficult to maintain. Another observation from this case was psychological. As her routine stabilized, she reported feeling more in control of her health choices. This sense of control is often overlooked, but it can significantly influence long term adherence to lifestyle changes. In clinical nutrition, one of the biggest challenges is not knowledge, but consistency. Many people know what to eat, but struggle to maintain it over time. Foods like makana are often used in dietary plans because they are simple, accessible, and culturally familiar in many regions, which improves long term adherence. From a physiological standpoint, improvements in inflammation and metabolic markers are typically gradual. They do not happen overnight, and they are influenced by multiple overlapping systems in the body. This is why follow up over weeks or months is necessary to observe meaningful trends. It is also worth noting that individual responses vary widely. Genetics, baseline health, medication use, and lifestyle all influence outcomes. What works for one person may not produce the same results in another, even with identical dietary changes. This is why modern medicine emphasizes evidence from large scale studies rather than individual cases alone. However, case observations still play a valuable role in understanding how theoretical research translates into real world application. What this example shows is not a miracle outcome, but a pattern that researchers often observe. When dietary quality improves consistently, multiple health markers tend to move in a positive direction over time, especially when combined with other lifestyle adjustments. In the final section, we will bring everything together. We will summarize what current science actually supports, what remains under investigation, and how Makana fits realistically into a modern understanding of nutrition, aging, and disease prevention without overstating its role or creating false expectations. Now that we have looked at the science, the traditional use, and the real world application, it is time to bring everything together and understand Makana in a realistic, balanced way, because one of the biggest problems in modern health content is exaggeration. A single food is often presented as a miracle solution, when in reality, human biology is far more complex. No seed, herb, or nutrient can override genetics, lifestyle, or medical conditions on its own. What we can say, based on current research, is more grounded and more useful. Makana, or Uriale ferox, is a traditional food that contains a combination of plant compounds, minerals, and carbohydrates that are now being studied in modern nutritional science. These compounds include flavonoids like quercetin derivatives and K-ampherol, as well as polysaccharides that have shown biological activity in laboratory settings. In controlled studies, these compounds have been observed to interact with processes related to oxidative stress, inflammation, and cellular signaling pathways. Some early research has also explored their effects on immune related cells and abnormal cell lines in vitro. However, these findings are preliminary and do not represent clinical treatments or proven medical outcomes in humans. At the same time, nutritional studies consistently show that whole foods like makana can contribute to overall dietary quality. Its low glycemic index, moderate protein content, and mineral profile make it a useful addition to balanced diets, especially when replacing processed snacks. One of the most consistent findings in nutrition science is that long term health is shaped more by overall dietary patterns than by any single food. Diets rich in whole grains, legumes, vegetables, and minimally processed plant foods are associated with better metabolic outcomes across populations. Makana fits into this category as a traditional, minimally processed food. When it comes to aging and stem cell research, the science is still developing. It is true that stem cell activity declines with age, and it is also true that inflammation and oxidative stress play roles in this process. However, the idea that a single food can significantly restore or triple stem cell production is not supported by clinical evidence. What is supported is that diet can influence inflammation levels and metabolic health, which indirectly affect how the body maintains and repairs itself over time. Similarly, in cancer research, laboratory studies on plant compounds are valuable for understanding biological mechanisms, but they are not the same as treatment outcomes. Compounds like flavonoids may show activity in cell cultures, but inside the human body, absorption, metabolism, and dosage all change how these compounds behave. This is why clinical trials are required before any medical claims can be made. Where Makana becomes practically valuable is in its role as a consistent, simple food that can replace less healthy alternatives. In many diets today, processed snacks high in sugar, refined oils, and additives contribute to metabolic imbalance over time. Replacing even a portion of these with whole foods like makana can improve overall dietary quality. Traditional systems of medicine did not rely on isolated nutrients. They focused on dietary patterns, timing, and balance. Makana was used as part of that broader framework, not as a standalone cure or intervention. Modern science is now revisiting these traditional foods to understand their biochemical properties, but the original context remains important. From a practical standpoint, the most realistic way to use makana is as a regular, moderate food within a balanced diet. Whether roasted, soaked, or combined with other ingredients, its value comes from consistency, not intensity. It is also important to remember that no food replaces medical care. Conditions such as cancer, diabetes, cardiovascular disease, or neurological disorders require professional diagnosis and treatment. Nutrition can support health, but it does not replace evidence based medicine. What makana does represent is something more subtle but still meaningful: the connection between traditional dietary knowledge and modern scientific curiosity. It is an example of how ancient food systems often contained insights that are only now being explored through laboratory research. Over time, more studies will likely clarify exactly how its compounds behave in the human body. Some findings may be confirmed, others may be revised, and some may not translate into clinical significance at all. That is how science progresses. For now, what we can say with confidence is this: Makana is a nutrient rich, traditionally valued food that contains bioactive compounds of scientific interest, and it can be part of a healthy dietary pattern when used appropriately. The broader lesson is not about one seed, it is about paying attention to how everyday foods influence long term health. Small, consistent dietary choices, repeated over years, are what shape metabolic health, energy levels, and aging far more than isolated interventions. And that brings us to the final takeaway. Health is not built through single discoveries or dramatic solutions. It is built through daily patterns, repeated decisions, and the accumulation of simple habits over time. Makana is one example of how traditional foods are being re examined through modern science. But the real power lies not in the food itself alone, but in the larger understanding that what you eat every day becomes part of how your body functions every day. That is the real story behind this ancient seed.